In this lesson, we're looking at Section A.3, our last section, which is converting US to metric conversions. It starts off by looking at a conversion that we've used before with a formula. And in the US customary system, we use degrees Fahrenheit. In the metric system, they use degrees Celsius. And so the conversion formula is Celsius equals 9/5 times the difference between the Fahrenheit temperature and 32. So using this, let's answer these true and false questions. So water boils at 212 degrees Fahrenheit. This is equivalent to 100 degrees Celsius. So let's plug in those numbers. C equals, so we'll do 100 equals, and that's supposed to be 5/9 times the temperature in Fahrenheit, which is 212 in the story problem, minus 32. So let's simplify. And we'll get 5/9 times 180. And when we multiply 5/9 times 180, we do get 100. So we get 100 equals 100, which is true. Okay, for our next question, it says water freezes at 0 degrees Celsius, and this is equivalent to 0 degrees Fahrenheit. Okay, so we'll plug in our 0 equals 5/9 times 0 minus 32. And we get 0 equals, and when we subtract, we get 5/9 times negative 32. And so when we multiply that, we get 0 equals approximately negative 17.8, which is not true. Okay. And now we're having when temperature is negative 40 degrees Fahrenheit, is also negative 40 degrees Celsius. Let's check that out. So negative 40 equals 5/9, and negative 40 minus 32. So we get negative 40 equals 5/9 times negative 72. And then negative 40 equals, and 5/9 times negative 72 is negative 40. So that one was true. And we're using those formula conversions to check those. So here's a chart that gives us equivalent measurements. Our US to metric is in the first column, and the second column is metric to US. And it asks how many meters are in 13 feet, round to the nearest thousand. So with 3 decimal places. And so use the equivalent measurement of 1 foot equals 0.305 meters, which is from our first column. Okay, so we have 13 feet. And remember, we can put that over 1 if we want to think of it as a fraction. And we need to get rid of feet, so the feet unit goes on the bottom, so we can cancel that. And the 0.305 meters, therefore, goes on the top. And when we multiply 3.965 meters. Now they want us to use the metric to US conversion of 1 meter equals 3.28 feet. So we'll start with our 13 feet, and we're multiplying it now by 1 meter over 3.28 feet. So again, our feet can cancel. And this time our 1 is in the numerator, 3.28 is in the denominator, so we're going to divide. And when we divide 13 by 3.28, round in 3 places, we get 3.963 meters. And so, are the values exactly the same, and why do you think this happens? No. They are, let's say, 2,000 different. And this is due to conversions being rounded numbers or approximations. So the more you round something, the more it could be further from the true value, just like we know with before using our pi. If we use 3.14 versus the actual pi button on the calculator that extends it more decimal places, we can get a little bit different. That's why. Is because numbers that were given in our chart is rounded, and so depending on which one you use is result of difference, and again in this case just some thousandths, but don't worry, I will know both answers, and so no matter which one you use, I will know that it's the right answer. Writing down your unit conversions, of course, is helpful. Personally, what I like to do is if they give me feet, I go to US first, because that way I'm always multiplying. If they give me the metric unit and want me to convert it to US, then I go to the second column and go metric to the US. Again, that way I'm always multiplying and not dividing. I think it's just easier that way. Here are some more unit conversions. Notice we have area and volume equivalents. And again, you will be given the charts to do any conversions with this. You're not expected to memorize this. The volume equivalents for cubic inches and cubic feet are found by using the length equivalent measurements and cubing them. Remember, that means taking them to the third power. This problem will guide you through finding the volume equivalent measurements between cubic inches and cubic centimeters. And so it tells us to start with the equivalent measurement of 1 inch equals 2.54 centimeters. And then cube each side of the equation. I'll put parentheses because we know the units need cubed. It's just easier to see it this way. And so 1 inch times 1 inch times 1 inch will still be 1, but it's in cubic inches now. And 2.54 centimeters times itself 3 times will give us 16.387 when we're rounding at 3 decimal places. And our centimeters are cubic. So does this answer match the charts here? It sure does. And then it asks, what is the other equivalent measurement involving inches and centimeters? Well, instead of 1 inch, if we look at the metric to US, we have 1 centimeter equals 0.394 inches. So if we cube these, okay, so let's cube them and see what we get. Well, we'll get 1 cubic centimeter, and 0.394 rounded 3 decimal places would be 0.060. We don't have to write that third number because it's a 0. And that's in inches cubed. And again, if we look at our conversion charts, we do see it right here. And so we are good. They match. And it's showing us how they got those numbers in that chart. The conversion between mass and weight is not exact. Weight is equal to the force of gravity multiplied by the mass of an object. The force of gravity on the object changes depending on the object's location. On Earth, the force of gravity is weaker at the top of a mountain than it is at sea level. This means that your weight will vary depending on your location. However, your mass stays the same no matter what location you're at. The equivalent measurement given in the table are for measurements taken at sea level. And so there's our conversions. And then they give us an example of changing pounds to grams. And notice we don't have anything that goes from pounds to grams, but we can go from pounds to ounces and then ounces to grams. And so let's look at their conversions. So here they canceled pounds and kept ounces, and then they canceled ounces and kept grams. So the units are okay, but let's look at the conversions. 16 ounces are in a pound, that's good. That was from our before US conversions, and then 1 gram is 0.035 ounces. That is right here in the chart. So that is good. So we're going to multiply 2 times 16, which is 32, and divide that by 0.035, and that gives us 914.3 grams. So that is correct. Here we have ton going to pounds. And so let's look at this. So we have 5 tons, and they're saying that there's 2,000 kilograms in 1 ton, and then 2.205 pounds in 1 kilogram. Okay, so let's look at this. This is TONNE, so this is a metric ton, and that's equivalent to 1,000 kilograms. It's 2,000 pounds in a US ton. So they mixed up that measurement. Then ton gets rid of ton, and then kilogram gets rid of kilogram, and we have pounds left over. And our conversion is good for the second one, that there's 2.205 pounds per kilogram. So again, the only difference is it was 1,000 kilograms in 1 ton. And so we have to change that. So we're going to do 5 times 1,000 times 2.205, which only gives us half of this, which is 11,025 pounds. So there's the mistake fixed. Okay. Use the information in the tables for the U.S. customary to metric equivalents to answer the following questions. Which is larger, a metric ton or a U.S. ton? It is a metric ton. Which is longer, an inch or a centimeter? It takes more centimeters to equal 1 inch, so the inch is bigger. And what has larger capacity? The quarts or the liter? And it is the liter. And again, you can look at your conversions to be able to answer those. So again, those were all through our lesson. Now that you've had some experience working with them, which system do you think is easier and why? This is your opinion, but personally, I believe that the metric system, because the conversions are way easier to calculate using that base 10, which means that we're just multiplying or dividing by powers of 10, which means we can just move those decimals. Here's some questions for you to do. Again, you can look at your charts. If you don't have your book open, this lesson started on page 615, so you'll need to flip through your book. Or in the Files tab in Canvas, you can print out the unit conversion chart to help you with that. And then when you're ready, check your answers and move forward with the story problems. In the United States, cola is sold in 2-liter bottles. How many fluid ounces are in each 2-liter bottle? Round your answer to the nearest hundredth. Excuse my voice, I'm a little froggy today. So how many quarts of cola are in each 2-liter bottle? So we're starting with 2 liters. And if we look at our charts, if we want to go with a 1 liter equals going from the metric TS, the conversion is 1.06 quarts are in a liter. So again, the liters cancel. We're keeping the quarts, and it is 2.12 quarts. Now we're going to use 2.2 quarts to determine how many pints. So 2.12 quarts. And then we need to go back to our US conversion of 1 quart equals 2 pints. So again, that way we can cancel our quarts, keep our pints, and 2.12 times 2 will give us 4.24 pints. And now it's asking us to determine how many cups. Excuse me, so we get 4.24 pints. And we're going to multiply it by 1 pint on the bottom to get rid of pints, and it's 2 cups per pint. And so we're doubling it again, and we get 8.48 cups. And now we're going to go to fluid ounces. Remember, it's 16 ounces in a pound, but it's 8 ounces in 1 cup. So don't mix your numbers up. So we have 8.48 cups, and we're going to multiply it by 8 ounces in 1 cup. And we're canceling out our cups, keeping our ounces, and we get 67.84 ounces. So that means there's 67.84 ounces in a 2-liter bottle of cola. And it says use a method from dimensional analysis to combine the multiplication or division by equivalent measurements from parts A through D into one step. So it's just writing it all together. So we have 2 liters times 1.06 quarts per 1 liter times 2 pints in 1 quart times 2 cups in 1 pint times 8 ounces in 1 cup. So again, we have our units canceling. Liters cancels liters, quarts cancels quarts, pints to pints, cups to cups. We're left with ounces. And 2 times 1.06 times 2 times 2 times 8 does give us our 67.84 ounces. So yes, it doesn't matter if we do them all together or one step at a time, we get the same answer. In the United States, sugar is typically sold in 5-pound bags. How many grams are in each 5-pound bag of sugar? And they want us to round our answer to the nearest hundredth. And so we have 5 pounds. So again, since they're giving us US, I like to go to the unit conversion that is US to metric. So we get 1 pound to help us multiply instead of divide, and the equivalent measurement is 0.454 kilograms. And if we multiply that, we get approximately 2.27 kilograms of sugar. And then use that answer to determine how many grams. So we're going in metric to metric. And so 2.27 is in kilograms. And again, if we think of our number chart, kilograms is all the way over to the left. Grams is in the center, which is 3 jumps away. So 1, 2, we need to add a 0 for our third jump, which will give us 2,270 grams. Okay, one more. In 2014, Winter Olympics were held in Sochi, Russia. Due to 2 consecutive mild winters, Sochi had to store approximately 588,000 cubic yards of snow under insulating blankets on nearby mountains to ensure they had enough snow for the skiing and snowboarding events. And so what is the equivalent measurement for yards to meters? And so it is 1 yard equals 0.914 meters. Now we're supposed to cube each side to find the cubic meters, and so 1 yard cubed is the same as 0.914 meters cubed. So we get 1 cubic yard equals 0.764 cubic meters. And so use this equivalent to determine how many cubic meters of snow were stored. And so our problem gave us 588,000 cubic yards of snow, and we're multiplying it by 0.764 cubic meters over 1 cubic yard. So again, that way our yards will cancel, and we're left with meters, cubic meters, and that gives us 449,232 when we round to the nearest meter, and again, that's cubic meters. So there you go. Again, make sure you use the chart while you're working through your homework. Have any questions, don't hesitate to email me, screenshot your question. Otherwise, I'll see you for our final review.